Lesson 13.6, Conditional Probability Formulas. Suppose the probability of rain on Saturday is 40%. What is the probability that you clean the garage on Saturday? So here's some extra information. There's a 90% chance of you cleaning the garage if it's raining. There is a 50% chance of you cleaning the garage if it's not raining. We will need that information to figure out this problem. When they ask us the question, what is the probability that you clean the garage on Saturday, we're really asking this question. What's the probability that there's a chance of rain and you clean if there's a chance of rain, plus the probability there is no chance of rain and you clean if it's not raining. So when we use the numbers, there's a 40% chance of it raining. The complement of that would be 60%, so that's no chance of raining. Then cleaning and it raining would be 90%. Cleaning and not raining would be 50%. So 9 times 4 is 0.36 plus 0.3. So we would have a 66% chance of cleaning the garage on Saturday depending on the weather. Here's a tree diagram. There's a 40% chance that it's going to rain. There's a 60% chance that it's not going to rain. Those two complements add up to 100. If it's raining, there's a 90% chance that I'm going to clean, which means if it's raining, there's a 10% chance I won't clean. If it's not raining, there's a 50% chance I'm going to clean. The complement of that would also be 50%. So if I look at my outcome, if it's raining and I clean, there's a 36% chance of that happening. Raining and not cleaning is a 4% chance. Raining and cleaning is a 30% chance. Raining and not cleaning is also a 30% chance. We want the probability that we are going to clean. So I see cleaning here and here, so we want to add the 36 and the 30 together, and that's how we get our 66% chance of us cleaning. So we're going to clean whether it rains or it doesn't, so those are the numbers that we are going to use. Here's a list of the standards that we are going to cover today. Conditional probability formula. For any two events A and B, the probability of B occurring, given that A has occurred, is this formula. So again, we're going to use this bar, and the second part after the bar tells us what our denominator is, and then we want to do the intersection of A and B in our numerator. So let's try an example. In a study designed to test the effectiveness of a new drug, half the volunteers received the drug. The other half of the volunteers received a placebo. It's a tablet or pill containing no medicine. The probability of a volunteer receiving the drug and getting well was 45%. What is the probability of someone getting well given that he received the drug? So looking at our information, here's what I decided to do. Set up a two-way frequency table, well and not well, and then receive and not receive the medicine. So I am letting A be the probability of someone getting well, and B be receiving the drug. So here's the formula from the previous slide, and we're going to switch that around a little bit because our events are named a little bit differently. So the formula says probability of B given A, but we want to find the probability of A given B. So what we're going to do is we're going to change this to an A, and we'll change this to a B, and this one doesn't matter because A and B or B and A is the same thing, and then our denominator is going to be the probability of B. So if you just want to write this out, this is what we're going to be doing. And here's our given bar. So let's fill in our chart. The probability of a volunteer receiving the drug and getting well is 45%. So we have to figure out where that happens. That looks like it's an intersection. So they received the drug and they got well. So this is where the 45% comes in. So B and A is 45%. Then, in the top of the question, it said half receive the drug and the other half get a placebo. So that means that half of the people receive the drug, so this total would be 0.5 if I added a total column, and not receiving would also be 50% of the people. So the total for receiving the drug would be half the people, so 0.5. So now we can figure out our formula. So we want to do A and B, 0.45, which is our numerator, divided by the probability that he receives the drug, 0.5. So if I work that out, that gives me 90% chance. So what is the probability of somebody getting well given that he received the drug? Well, according to this experiment, 90% of the time a person will get well given that they received the drug. Let's try another one. In a survey, half the students walk to school and the other half take the bus. Out of the students who were surveyed, 35% took the bus to school and played sports, and 20% walked to school and did not play sports. So let's try to fill out our chart. So the first number I noticed, it says half the students walk and the other half take the bus. So that means on our total column, this is going to be 50% and this would be 50%. So again, we want to set up a two-way frequency table. I think it helps us answer the question. Out of all the students who were surveyed, 35 took the bus and played sports. So bus and played sports would be here. So this is 35%. 20% walked and did not play sports. So these green numbers were the givens. So again, I'm going to add a total column. And then this should be 1.0 or 100%. So I should be able to fill in my table. So our walkers have to add up to 50%. So if 20% were not in sports, that means we had to have 30% in sports to make our total. And then for bus riders, if 35% were in sports, then 15% were not in sports to make our 50%. And then I can do my sports totals, so that would be 65, and my non-sports totals would be 35. These are the numbers that we're going to need to answer the question. Number one, what is the probability that we play sports given that the student takes the bus? So this number tells us what our denominator is going to be. So I'm going to highlight that column. So out of all the people that take the bus, out of 50% of the people, how many play sports? 35. Divide that out on your calculator and you get 70% of students. The next question says, what is the probability that a student plays sports given that they walk to school? So out of all the kids that walk to school, what is the probability they play sports? So my denominator again is 50%. And then I want to know out of those blue kids, how many play sports? So I'm looking at the 30%. Divide that out, and I get 60% of students play sports given that they walk to school. So this condition tells us what section to look at. Out of all the bus riders, so out of all the pinks who play sports. Walking, out of all the walkers, that's the condition that has to be met. How many play sports? Number 3, what is the probability that someone who walks to school does not play sports? So what this one is asking, what is the probability that they do not play sports given that they walk to school? So out of my walkers, out of the blue, so that's 50%, how many are not in sports? 20. So this would give us 40% of kids.